In question number 10.4, which one of the following has the highest dipole moment? So three compounds are given here and we have to decide that which one should have highest dipole moment. So first one is CH2Cl2. So this one is the first one. CH2Cl2, we can make the structure carbon at the center, one chlorine here, second chlorine here, and third is hydrogen, and fourth one is also hydrogen. So this is the position of chlorine and hydrogen in the compound CH2Cl2. Now what happens? Chlorine is a polar molecule. So two dipoles are towards chlorine. So this dipole we can make like this. This is towards chlorine, it should have arrow, and here it is plus sign. Here also the same thing. Towards chlorine, it is, this dipole is here. And the resultant of these two should be here. And similarly, here hydrogen is non-polar molecule and the bond is non-polar. So as compared to hydrogen, we can say the polarity is slightly towards carbon, and here also it is slightly towards carbon. And the resultant of these two should be here. So in case of CH2Cl2, what happens actually? The resultant dipole moment of two carbon chlorine bonds is strengthened by this resultant of dipole moment of two carbon hydrogen bonds. This is further strengthened in the same direction, and that is why the dipole moment here is equal to 1.6 D. Whereas what happens in the second case? In the second case, the compound given is CHCl3, that is chloroform. So here also we can assume that carbon is at the center and one hydrogen is here, and the second hydrogen, this should be chlorine, and here also one chlorine, and here also one chlorine. After that, we know that carbon-chlorine bond is a polar bond. So here, again, this bond is polar. So we can show the dipole moment. And here by this arrow, we can show the dipole moment. And resultant of these two should be this one. So this is the dipole moment. And here, carbon-chlorine bond is again polar. So we have to make the dipole moment like this. It should be, arrow should be towards chlorine, and here again it is towards carbon, because it is non-polar bond. So what happens? Resultant of these two should be here. One is hydrogen, other one is chlorine. So resultant is upward here. So in this case, we can say that in CHCl3, the resultant of dipole moment of two carbon-chlorine bond is opposed by the resultant of one carbon hydrogen and one chlorine bond. It is opposed by this arrow, small arrow. And this opposition is slightly, and that is why the dipole moment should decrease. The total dipole moment of the molecule should decrease. Since the resultant of one carbon hydrogen bond and one carbon chlorine bond is smaller than the two carbon chlorine bonds, CHCl3 has a smaller dipole moment as compared to the first one, and it is equal to 1.08. D. This deeper. So this is the second one, and the third one is slightly different. This is second one, and third one is here. It is carbon tetrachloride. So overall, this molecule should be non-polar because all are carbon chlorine bonds. So one should be cancelled by the other. One dipole should be cancelled by the other one. And overall molecule should be non-polar. So here by the diagram also we can show that here this bond is polar, this bond is polar, and resultant of this should be here. Similarly, this bond is polar and this bond is polar, and resultant of this should be here, which is exactly equal to this first one, and by that it is neutralizing the effect. So we can say carbon tetrachloride is a symmetrical molecule. Therefore, dipole moment of all four carbon chlorine bonds cancel each other. So the resultant is equal to 0. So here the answer is CH2Cl2 has the highest dipole moment. This dipole moment of the third one is equal to 0. So here we can say that the highest dipole moment is in this case